Hey everyone. So today I want to talk a little bit about reaction mechanisms. We've gone over reaction mechanisms before. I kind of rolled it into the elementary steps lecture, where you propose a reaction mechanism, and you go through. Remember that the slow step is going to be your actual rate law. Whenever you're looking at elementary steps, at the individual steps there, that the coefficients actually do equal the order of the rate law for that elementary step, and then the slow elementary step, that its rate law for that elementary slow step is the rate law for the entire reaction. Okay, so we talked about that. I have a little 2-page worksheet I want you guys to go through and kind of follow through. There is one thing that I didn't mention, and that's whenever your slow step is behind step 1. Everything I mentioned in my previous lecture, the slow step was first. And you have to do something a little different here. Kind of let me show you. I got some examples here. Let me make this a little bit larger. All right, so we have this reaction, and we have a reaction mechanism here where the slow step is first. Okay. Now, when we have this, let's kind of just run through this real quick. Just come on. Oh no, it won't let me do it. Oh well. So this slow step, remember, we can take these coefficients, and that is the order of the rate law for this elementary step. And we can do the same thing for the fast step. Now, the slow step is going to be the thing that's taking the longest. It's the rate determining step. It's the longest thing. Remember, it's kind of like, how if someone's building a car, it takes 3 hours, hands it over to me, I slap a hood ornament on it, and then that's that. It's the slow step is taking all the work. So we can say that this rate law is the rate law of the entire thing. And that kind of makes sense. If we look here, geez, why do I keep doing that? Remember that the rate law is rate equals K, concentration of your reactants raised to some power. Okay. And that works out here. This rate law are these reactants raised to some power. Both of them raised to the first power. Okay, great. That's fine. But what if we have this example where the fast step is followed by a slow step? We have a reaction here, 2 nitrogen monoxide, and oxygen goes to 2 nitrogen dioxide. And the mechanism is as follows. You have step 1, it's fast. 2 nitrogen monoxide goes to N2O2, dinitrogen dioxide. And we have its rate law here. Remember, the coefficient of the elementary step equals the order of this reaction. Then we have the slow step. Remember, this is the thing that actually takes all the time. And here's the chemical reaction and its rate law. Again, coefficient of 1, order 1, order 1. First order, first order. Now, here's the thing. Normally, we would say, okay, this is going to be the rate law of the entire formula, of the entire overall reaction. But where in this original reaction is N2O2, dinitrogen dioxide? You can't find it anywhere. It's not a reactant. It's an intermediate. So what do? Remember that your overall rate law can't have intermediates in it. because they're not in the overall reaction. So what do we do? What do we do? Well, this is kind of the thing, is that we have to think about how quickly does dinitrogen dioxide come about, and how quickly are we using it up? So what does that mean? Mathematically, you can go through and write it like this. We have the rate constant 1 in O2. That's the this rate. The how quickly are you making this? It's going to be the reverse as well. How quickly does it back away? This is a reversible reaction. We'll talk about more about that when we get to equilibriums. But we can just rearrange this to this rate law. The concentration of N2O2 equals these rate constants times the concentration of nitrogen dioxide to the second. Essentially, this is what we're doing. Since we're making N2O2 in the fast step, and this is how quickly we are making N2O2, what we can do is plug this into the slow step, and our rate in the end is going to be NO2 O2. We take this and we replace the dinitrogen dioxide concentration with this rate law up here. Nitrogen monoxide squared is going to go into here. Okay. Here's a video that can kind of go along with that as well. Let me kind of just run through this. So again, what you're going to have to do here to figure this out is, 1, determine the overall reaction of these guys, doing the same thing we did before, where we cancel out things. This is an intermediate, so we cancel it out. Let's see, what else is an intermediate? This gets canceled out, and I think that's it. Yeah. So you're going to have to go through and cancel things out, write out the entire thing. I just showed you the intermediates. Determine the rate law. Geez. Now this is going to be the hard part. You're going to need to write out the elementary rate laws for these three things. The slow step is going to be your rate limiting step. So it's going to be this. I can't use an intermediate, so then I have to look above to the step above it and put its rate law in place of into O2 in this case, since that's the intermediate. Okay. Then, last thing here. Let me kind of bring it back over here. The overall rate law, which is this right here, is third order, right? It's NO squared times oxygen concentration. So this is going to be third order here. But let's look at that slow step. Okay, looking at this slow step, how many molecules are actually banging together in the slow step? Just two. Just two. So is this reaction, even though it is third order, the overall reaction is third order, the slow step, there's only two molecules banging together. So this is bimolecular. So those are a couple things you need to to think about and remember. This only really comes into play whenever the slow step comes after the fast step. If the slow step comes before the fast step, you can just take this rate law and move on. So, yep, this is the slow step. This rate law is the overall rate law, and just move on. But whenever the slow step is behind after the fast step, what you'll need to do is replace intermediates with the rate law above it, and then that is going to be your overall rate law. Okay. Hopefully that helps. We'll talk about this on Thursday. But for right now, you watch this video and fill out this 2-page PDF. We'll go over these answers. This is, again, kind of like the notes thing. I just want you to run through these, and then we'll answer it on Thursday. All right, guys. I will see you guys Thursday.